So a linear function is usually going to be in the form y equals mx plus b. Okay, it has an x where the exponent's 1. And the graph is a line. Okay, slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. Function notation, remember, is f of x. It's the same as y. Slope is the direction and steepness of a line. The y-intercept is where the graph crosses the y-axis. So the point would always be 0 and then a number. The x-intercept, 0, sometimes they're called roots, solutions. It's where your graph crosses the x-axis, and it's always a number in the x spot and 0 in the y spot. Okay, so let's look at these. A feather was dropped from the top of a 100-meter building. It fell at a constant rate of 0.5 meters per second. Represent this function with a table, graph, and algebraic generalization. Determine the slope, y-intercept, x-intercept, and 0 of the function, and explain their meaning. Okay, so there's a lot to do here. All right, so what we need to do first, the 100-meter building, that is our B, that's our beginning where we're starting. So if we were to write this in slope-intercept, that would be our B value. It fell at a constant rate, so it's falling at 0.5. So that's our slope, so that's negative 0.5x, because we don't know how much time has passed yet. Okay, so when we graph this, we start at the B value. So this is our begin point. It also shows up at the table, so you would start here. So we're going to start at 0, 100, because this is x, this is y. And then we're going to just kind of graph the whole numbers. So our graph is counting by 20s. So I'm going to focus on those values that are going to be easier to graph. So 20, 90, 40, 80. If we keep following this, it would go 60, 70. And then 80, 60. 150, 120, 40, 140, 30, 160, 20, 180, 10, and then 200. Okay, since this feather is falling at a constant rate, we need to go ahead and connect all of our dots. So since we are connecting, that makes this function continuous. Okay, so that means for our domain and our range, we're going to need, remember, we need inequalities. So for my domain, I'm going to focus on the x values. There's no arrow, so I'm going to draw my inequality. My first x value is 0, and it's equal at that spot. My last x value is 200, because it's not going to keep going once it hits the ground. Okay, so for my range, I'm going to start at the bottom of the graph, so 0, and I'm going to go all the way to the top of my graph, so that would be 100. The type of slope. So since we're going down, this slope is negative. Okay, the y-intercept. Remember, that's where we begin. So our y-intercept is 0, 100. Okay, and that's where the feather started. All right, our x-intercept is the point where it touches the x-axis. All right, so the x-intercept is 200, 0, and that's telling us that it took 200 seconds to hit the ground. Okay. All right, on this next one, we are going to go ahead and ignore this graph. It says Tommy's mail order toffee company charges $17.50 per tin of toffee plus a $10.25 shipping and handling fee per order. Okay, so we're going to go ahead and make a table. We have x, we have f of x. Remember, that's the same thing as y. Okay, so charges $17.50 per tin. That means that's where my x goes, because I don't know how many tins. So we have y equals $17.50x plus we have to pay this $10.25. So that's the b value. Okay, so that means at $10.25 at 0, I am paying my shipping and handling. Okay, so that's the beginning. Then you can put this equation into Desmos or just plug in x values. So at 1, for 1 tin, it would cost $27.75, 2, $45, 25, 3, $62.75, 4, $8.25, 5, $97.75. Okay, since we're not going to sell half tins, we're just counting tins, this is going to be discrete. Okay, so our domain is just going to be 0 with the numbers we used, 1, 2, 3, 4, and 5. Our range is going to be 10.25, 27.75, 45.25, 62.75, that should probably be 88.25, and then 97.75. Okay, so these numbers are increasing, so our slope, if we were to graph it, would be positive. Okay, my y-intercept in a table is always where x is 0. Okay, So the y-intercept is 0 and 1025. So that represents the shipping. Okay, in this one, since our graph is starting at 0, 1025, it's never going to touch the x-axis. So for x-intercept, you would write none. Don't write 0. Go ahead and write none.